Module 5, Lesson 1, ELLN. Inquiry-based approach. Read the two scenarios below. Scenario 1, the teacher defines multiplication to the students and then shows a multiplication sentence. She presents the following problem to the class. Miss Anna teaches 4 classes in one of her classes. The students are seated in 4 rows. Each row has 6 students. How many students does she have in that class? That is the scenario number 1. Scenario number 2. The teacher presents a problem. Miss Anna teaches 4 classes in one of her classes. The students are seated in 4 lines. Each row has 6 students. How many students does she have in that class? The teacher then asks the students to answer the question using cubes. She lets the students in each group discuss how they are going to solve the problem. What do you think is the example of an inquiry-based approach in the two scenarios? So let's find out. In inquiry-based lessons, the teacher guides students as they actively explore a topic and discover on their own the answer on an open-ended question. Instead of lecturing or demonstrating what should be learned, the teacher constructs a learning environment and designs learning tasks for students to explore the target math concepts and discover the answers for themselves according to strategies for teaching elementary and mathematics 2028. So these are the characteristics of inquiry-based learning. Process-oriented. Inquiry-based learning is focused on the process used to arrive at the answer, not the answer itself. It is through the process of figuring out the answer that the student constructs meaning and internalizes concepts. Balance. There is a balance between content and procedure, since math involves particular ways of thinking and not just specific content. Investigation. The students explore and investigate concepts and processes that are embedded in a problem which is dictated by the content or by the student's questions. Collaborative learning. Students work in pairs or small groups, followed by a whole class discussion towards the end of the lesson. Thus, students learn to articulate their thinking, brainstorm, and build upon and test ideas as they work toward a solution. Multiple methods and strategies. Different problem-solving methods and strategies to arrive at conclusions are allowed. Since there is usually more than one strategy for solving a problem, and different children know different strategies. Teacher as guide. Instead of giving the students the answer directly, the teacher uses questions and prompts to help students to visualize a problem and arrive at the correct conclusion through their own problem-solving strategies and understand the concepts involved. This means that the teacher should understand the concepts very well and know the various ways of solving the problem. Questioning and monitoring. The teacher goes around and listens in on the students' discussion as they work on the problem in order to assess the students' understanding and to identify possible misconceptions. Adaptive teaching. The teacher needs to constantly reflect on the students' responses and their observations and adapt the lesson accordingly. Real-life applications. The problem that students are asked to explore are articulated such that there is clearly a real-life, meaningful application. Using math tools. Students are given math tools such as rods, and blocks to help them visualize the problem and bridge the gap between concrete and abstract thinking. Using these tools also helps in explaining problem-solving strategies. Communicating. Students identify and formulate problems for investigation, express their ideas, and work through the problems by visualizing and explaining. They also present their work to each other and provide constructive feedback to work of their peers. Materials for teaching math. Selecting the right material is an important step in planning your students' learning experience. Different types of learning materials are appropriate for different stages of cognitive development. Periods of development, sensory motor, pre-operations. How concepts are required. Naturalistic and formal or structured. Sensory motor in a naturalistic, objects and pictures, real objects, same. Pre-operational, real objects, subject and pictures, cutouts, pictures. Same lang din. But in informal and structured, they are using calculators. So mathematics give us hope and that every problem has a solution.